Welcome back. This is Prep Station Chemistry. In the last episode, I showed you how to solve for currents used to discharge ion, and also how to find the number of grams of metals or ions that you deposited during electrolysis. Now let's proceed to the third question. This question says, how many coulombs? This one is a straightforward question anyway. How many coulombs of electricity are passed through a solution in which 6.5 amperes are allowed to run for 1 hour? This one is just a straightforward question. So what do? Look at the parameter given. You are given time and you are given the current in the question. So your 6.5 amperes is your current, while your 1.0 hour is your time. But you cannot use hour in this case. What do? You convert the hour to seconds. So how do we do that? By multiplying 60 to it, because 60 seconds make 1 minute. So how do you do that? So when you do that, you now have 6.5 times 60 times 60, all right? So whatever you have is your answer, because you're looking for only the quantity. So it's a straightforward question. If you do that, your answer will be option D, as you can see on the screen, 2.34 times 10 to the power 4 coulombs. All right, let's proceed. Question 4. A quantity of electricity liberates 3.6 grams of silver from its salts. What mass of aluminum will be liberated from its salts by the same quantity of electricity? All right, so this question is like a 2-in-1 question. First of all, you must find the quantity of electricity that silver need, because this particular question comes from electrochemical cells, in which you have 2 setups of electrolytes. Now, first of all, look at the parameter. What is given, so you know how to play with the question. You are given 3.6 grams of silver. Okay, that is the reacting mass that is deposited in electrolysis. But you're asked to find the mass of aluminum that is even deposited. So you cannot do this without getting the quantity of electric current that is used. So how do you do this? Get the half equation of what? Of the cathode, because silver will be discharged at the cathode. So write your cathodic reaction, which is Ag. As you can see, Ag is +1. That will now gain 1 electron and becomes what? Ag, neutral atom. And this is 1 Faraday. Of course, 1 Faraday equals to 96500 coulombs. Then what is the molar mass of silver is given in the question? 108 grams. So now, if 108 grams is being discharged by 6500 coulombs, what will 3.6 grams, current? What will be the currents to discharge 3.6 grams? When you cross multiply, you have 3216.7 coulombs. All right. So this is what you will use to do what? To get the mass of aluminum that is being deposited. When you are done with that, now go and this is Ag, supposed to be Al. Write half equation for what? For aluminum. Okay, aluminum is Al plus what? Plus 3. And they now gain 3 electrons and become what? A neutral atom. So aluminum is now discharging 3 electrons. We refer to what? 3 Faradays. So multiply 3 by 96500, you have 298,500 coulombs. That will discharge what? 27 grams of aluminum. So therefore, what will 321 grams of coulombs discharge, because they are connected what? In series. If you cross multiply this, you now have 0.30 grams aluminum. So that is the mass of aluminum that is discharged. If you check your option, that falls in option D, which is 0.3 grams. Please note very well, this question is not a straightforward question. So go through the question very well, study it with understanding, so that if you see such a question, you know how to do what, how to tackle it. Now let's check another example. 5. Which of the following statement is correct? If 1 Faraday of electricity is passed through 1.0 mole CuSO4 solution for 1 minute. This is a very straightforward question. The answer there is B. The pH of solution at the anode will surely decrease because of the discharge of what? Of H2SO4. All right, let's move on. What mass of magnesium will be obtained by passing a current of 2 amperes for 2 hours, 30 minutes? Now, if you look at this question, they only change magnesium. If you check the previous one we have solved, when they mention aluminum, they mention copper. It's the same format. So what they do here, they only change the metal, the ion, and change the time. Okay, so the format remains the same. So how do you tackle this? First of all, find the quantity. You are given time. How many time? You are given 2 hours, 30 minutes. So convert these 2 hours to seconds. So 60 plus 60 plus 30 times 60 will give us the conversion. That will give us 9,000 watts. That will give us, yes, 9,000 seconds. Multiply by what? The amperes, which is your current, you have 18,000 coulombs. After then, write half equation. Don't forget to write half equation and balance it. Don't forget to do this. If you don't know how to do this, you can't solve problem on electrolysis. So write your half equation, and you must know the charges of most of the metals. Very, very important. So magnesium is a group 2 element. So you must surely do what? Gain 2 electron. Okay, to become what? A neutral atom. Are you getting it? So now the question is, they're looking for the reacting mass. The given mass is already 24, which is the molar mass of what? Of magnesium. Okay, so now what will be the mass discharge at the electrolysis? So when you do your normal cross multiplication, you have 2.24 grams of magnesium. So the option here falls for C. So C here is your correct answer. Please take notes. The format remains the same. You need to know the half reaction, where it takes place, and how many moles have been deposited. If you do that, your problem is less. Okay, let's move to the next question. Which of the following reaction takes place in the cathode compartment during the electrolysis of copper 2 chloride? Now, first of all, you must know what is a cathode. A cathode is a negatively charged electrode that must attract positively charged ion. So if you break this compound down, you will have copper 2 chloride is CuCl2. That will give us Cu2 plus and what? Cl minus. So this copper here will be discharged at what? At the cathode. So if you write a balance equation for this compound, you can see your answer is what? Is A, which is Cu2 plus 2E minus. Then you have your what? Your copper. So take notes. But if you ask of chloride, chloride will be discharged at the anode. Okay, because of what? Because of higher concentration. The next question is number 8. The same current is passed for same time through solution of silver nitrate and copper 2 sulfates connected in series. How much silver will be deposited in 1 grams of copper? Now, if you check question, so let me take you back. If you check question 4, there is no difference with question 8. The only difference there is they have changed the metal, the compound, and the time. But the approach to the question is the same. So if you know one, you know all. Just try to understand how to tackle any question, understand the question, how to start. You will not have much problem on electrolysis calculation. So now, let's go back to that question again. Now, 2 questions are mentioned. 2 compounds are mentioned. So what are we looking for actually? We are looking for the mass of the mass of silver that will be discharged at the end of this electrolysis. But what is given? What is given? You use the known to find the unknown. First of all, start with the copper, because copper is mentioned. All right, 1.0 grams of copper is produced, which is your reacting mass of copper. All right. So how many electrons have been gained? Is 2 electrons, which stand for what? 2 Faradays. I hope you're getting it. Then multiply that 96500 by 2, you have 19300 coulombs. That will produce, this is the given mass of what? Copper. So what quantity of electricity will give us 1.0 mass of copper that is discharged? So when you cross multiply this, you have 3039 coulombs. This is what you will use because it is connected in series. This is what you will use, okay, to do what? To get the mass of silver that is being discharged. Silver now lost or gain only 1 electron, which is 96500. That will give us 10.8. Okay. So now, what will be the mass in which this current 3039 will produce? So when you do your cross multiplication, you have 3.48 grams of what? Of silver. So your option here, the right option here is option B, after you've passed through the calculation on it. Okay, let's check another example. What is discharged at the cathode during electrolysis of copper 2 sulfate? We have done this before. Where is cathode? Negatively charged electrode. So when copper dissolves copper 2 sulfate, it will give us what? Copper ion and what? SO4 sulfate 6 ion, SO4 2 minus. All right. So because Cu2 plus is a cation, so it will be attracted to what? To cathode, which is a negatively charged what? Electrode. So it is Cu that will be discharged. Don't forget that this electrolyte now, water is involved. So we have H2O. If you break it down to the ion, you're going to have what? H plus and what? SO minus. Now going down to your electrochemical series, copper is below what? Is below hydrogen. So that is why copper is discharged, not hydrogen at the what? At the cathode. So cathode here, okay, cathode here will now be attracted to the positively charged what? Ion. So the right option here is A, not B. Take note of it. Let's move on. Question 10. I brought so many questions so that you will be conversant with how to tackle problem with electrolysis. There are many questions regarding electrolysis, but this is where students, okay, find it so difficult to answer. So that is why I am so concerned with the Faraday's law in this electrolytic discussion. So question 10 says, if 10.8 grams of silver is deposited in a silver colorimeter connected in series with a copper colorimeter, the volume of oxygen liberated is, now this one they have changed, they have swapped. They are looking for the volume of what? Oxygen. So you must be cautious of what they are looking for. Other examples were mass to mass, but this is mass to what? To volume. So, and we mentioned what? Oxygen. So don't forget that oxygen will always be discharged at where? At the anode. So you must write what? You must know how to write the anodic half equation for the discharge of what? Of OH in the electrolytic cell. So how do you get there? First of all, look at the parameter that is given. We are given the reacting mass of silver, which is 10.8. 10.8 is your reacting mass in silver colorimeter. So We, of course, we know how to write half equation for silver. Ag plus A minus give us Ag. So now, what quantity of electricity will give us this 10.8 grams? Okay, so when you do your cross multiplication very well, according to what you see on the screen here, all right, you cross multiply this, you're going to have your coulombs, 9650 coulombs. All right, now, this is the quantity you need, okay, to get the volume of oxygen that is discharged at the anode. So, when you do your half anodic reaction, you know that you will get 4 moles of oxygen, okay, that is discharged. 4 Faradays will be discharged from your balancing. Okay, so now if 1 Faraday is 96500 coulombs, what will 4 Faradays give you? Simply multiply 96500 by 4. If you do that, you're going to have 386,000 coulombs. All right, so what is the standard volume of a gas? So even if you're not given, know that it's what is always 22.4 dN cube or 22,400 cN cube. But here you are given in dN cube. So now your question is, what is the actual volume of their specific here? They mentioned oxygen. So now, if 386,000 coulombs, okay, can give us 22.4 dN cube, all right, then what will this coulomb gotten from the first answer give us? Don't forget how we go about these things. So therefore, 96044 will give us what? You cross multiply. When you do that, your answer will be what? 0.56 dN cube. Looking at the option, the correct option there is what? Is A. These questions, this is how JAM twists their question to confuse students. But if you know what you're doing, you will never be confused on how to solve this. Pay attention to the question and know what you are asked to find. Okay, let's move on. This one is how to find number of Faraday. A 0.1 Faraday of electricity deposited 2.9 grams of nickel during electrolysis in aqueous solution. Calculate the number of moles of nickel that will be deposited by 0.4 Faraday. It's simple. Now, this one is a straightaway solution. Look at the question again, pick the parameters, and know exactly what you are asked to do. You are looking for number of moles. So here you don't need much protocol. The question, the parameters are given already in the what? In the question. So capture them accordingly. So if 0.1 mole Faraday, okay, give us 22.9 grams according to the question, then what will 0.4 give you? Just simple, cross multiply. So that will give us what? If you cross multiply properly, you now have 11.8 grams of nickel. Because 0.1 give us 2.95 grams. Then what will 0.4 give us? Simply is a matter of cross multiplication. But you must know how to place this. If you don't know how to place this, that's what the problem is. So you must learn how to place this so that you will not do the reverse. Don't forget that all these questions, all these options, they are answers based on how you solve it. If you solve it the wrong way, you will see answer among the question, among the options. So you must be careful on how to place your figures in order to get your right words, your right answer. Now, when you now get your mass, what do? Don't forget the relationship between molar mass, reactive mass, and mass. So how do you get number of moles? You divide the reactive mass by the molar mass. So your reactive mass is 11.8 grams nickel. All right? So now what is the molar mass of nickel? Go to your question you are given, which is 58.7. If you divide 11.8 by the molar mass, you now have what? 0.2. So that is your what? The number of moles that is obtained during this electrolysis. Okay, so let's take a brief break. When we come back, we'll continue from here. Thank you.